Blockchain stealth addresses. So the typical and probably simplest stealth address is HD wallet address or hierarchical deterministic wallet address. This is one of the most famous and most common current wallets that you get. If you go to MyEther wallet or any other wallet, they most likely support HD wallets. And the idea is you have this initial seed phrase right here where you have the seed. This might be a 12 or 24 word character, which basically represents your private key. And from this private key, you then derive a number n of addresses that you like to use. And if you use, for example, address 1, then there's no way to deduce from address 1 address 2 for an external observer, right? This is not possible. And this means that they're kind of isolated, right? So you can't really you can't infer the complete wallet from a user. Yeah, this is quite a handy property, I would say, which improves privacy of users in general. And that's a form of stealth address. Now, in general, a stealth address is something where you have a payer. The payer receives a stealth address from a receiver, or this can be like a one-time address from the receiver, and then the payer pays a transaction towards the receiver towards this address. And ideally, here the adversary should not be able to see where this transaction is paid to, and you can have the support of a scanner, which is like a third-party auditor that can actually see what's happening. So one other stealth address way, which was implemented by the dark wallet, there's nothing dark about it, it's just a privacy-preserving wallet, is the following. So you have a receiver, he has the spend key, and you have a scanner, which has a scan key, right? And from the private key, you can always derive a public key, right? And so given the scan public key and the spend pub key, the receiver can then generate a stealth address. Now, the stealth address, he receives this particular, the payer receives this particular stealth address, and he generates a temporary FM key, right, from which he generates a pub key, and then this generates a stealth pub key. And this stealth pub key is a particular base 58 Bitcoin address. It's not a standard one, it's some particular address, but this is where he will pay towards, right? So he will pay towards this particular address. And this address is not the same as the stealth address, right? And you can't derive from the Bitcoin address the stealth address either, if you just observe the blockchain data. All right. And there might be some additional metadata, right, which the FM pub key can provide. So now if you want to receive this coin, right, so the receiver, he actually for example, can be in contact with a scanner, right? The scanner has a scan key. The scanner knows about the stealth address, so he can scan all the blockchain transactions and then identify, given some stealth metadata as well, the stealth pub key, and hence he can observe whether a particular blockchain address received funds or not. And if this Bitcoin address received funds, he can notify the receiver you've received a transaction. So how do you spend now those coins? Well, the receiver has stealth address. He gets the IFM key, right? And given this, he basically has a way to spend to identify this Bitcoin address. So what the receiver does here, he's taking the scan key, taking the spend key, generating a new private key that's the stealth key, given this additional metadata. Right? So, and given this private key now, he's able to spend the coins that we received on this particular Bitcoin address here.